Good day, my name is Stephanie van der Kerk, and today I will be doing a presentation on the Vaal Town Limpopo Road R33 section 60.8 to 63 kilometers. Project overview. I am required to upgrade a road in the Vaal Town Limpopo to a 4-lane road. The upgrade is for the duration of 60.8 kilometers to 63 kilometers. I utilized Civil 3D as my design software. The assumptions made during the course of this road design is that the pavement structure has 50A wearing course layer, 150 mm G1 base layer, and 300 mm C3 subbase layer. It has a CBR of 9% and a standard deviation of 1.16. The road category is classified as Class A. My final design covered the following aspects: alignment design using Civil 3D for a given road section, a detailed manual calculation of one horizontal curve and one vertical curve, an Excel sheet to replicate the manual calculations for future analysis of manual curves, earthwork designs and mass flow diagrams, and a conceptual design of the stormwater system. This project location takes place as illustrated in the first figure, and that is the road that needs to be upgraded and its location. The road runs from 60.3 kilometers to 63 kilometers and is situated on the R33. The second figure illustrates the road network and also other roads leading into the main road of R33. The existing road description and motivation for upgrade. Currently the road is on ground level with gravel sidewalks. It also has silt sedimentation depositing onto the road, and trucks make use of the shoulder for parking, and pedestrians walk on the shoulder and cross main roads at any given time, which is very dangerous. There are also multiple intersecting roads into R33. The road also would not be able to withstand the growth rate of 5.9% following the next 30 years. Below, I've also added an illustration of the current R33 road along with its gravel sidewalks and illustrating that the road is on ground level. Survey data. My first action to improve the road is to improve the road alignment and improve the road conditions. The surface of the road was also assessed to determine the best suited concept for my design. The environment was assessed to determine the impact it would have on its surrounding area. I also conducted a site survey, and the survey data included changes, short spots, and a layout of the existing road. In the figure on this slide, you can see the imported 3D view of our survey data. Hand calculations. First illustration is a manual check of the horizontal curve. You can also see that my delta is 10.768. The curve length was calculated as 15.035. My tangent length is 7.540. My PI chainage is 2886.278 meters, and my EC chainage is 2893.773 meters, which correlates with the snip shown on the right from my design data. I also did a manual design check of my vertical curve, and the VPI level is 1171.965, which also correlates to the vertical curve which was obtained from my design data. And design. In our project brief, our road has an average CBR of 9% and a standard deviation of 1.16. According to Table 16 in the TRH4, A road is classified as SG2 due to the subgrade value that lies between 7 to 15%. Table 16 is added in this slide as an illustration for our SG2, which has a subgrade CBR of 7 to 15, which in our case is 9%. I've also added table 22, which is the preparation of subgrade / roadbed and requirement selected layers for different subgrade design CBRs. For our case, SG2, our design CBR of subgrade 7 to 15%, which in our case is 9%, has an added selected upper layer of 150mm G7 and a treatment of in situ subgrade, which is ripped and recompacted to 150mm G9. I've also added table 1 in addition to our previous slide. The road category is category A as discussed in our previous slides, and the description is that it's a major interurban freeway and major rural road. The importance is very important and it has a service level of a very high level of service. The pavement characteristics risk is very low and it has an approximate design reliability of 95%. I also added table 15, which is the typical material depths used for determining the design CBR of in situ subgrade. Since our road category is category A, the material depth is 1000 to 1200 millimeters. I added table 2 for the typical analysis period for various road categories. In our case, we're looking at road category A, which ranges between 20 to 40 years, and it has a high certainty recommended period of 30 years, and it doesn't have a low certainty recommended period. I also added table 3, which is the typical structural design period for various road categories. In our case, road category A, the structural design period ranges between 15 to 30 years, and it is a recommended 25 years. I also added my hand-free sketch, which includes 50 asphalt wearing cores, 150 G1 base layer, and a 300mm C3 sub-base layer. Drainage. I made use of Sandrail Drainage Manual to determine my road surface drainage requirements. For the main pipeline, I made use of 520 diameter pipes, and at the curb inlets, I also made use of 520 diameter pipes. Manholes were placed at 80-meter intervals to not exceed the distance of 90 meters. In the snip added on the slide, you can see that I added the 520 diameter into my design data. Excel tool. The Excel tool was just used to check my horizontal curve as well as my vertical curve, and it coincides with the previous hand calculation checks that I've done on previous slides. This is a very helpful tool that can be used for the future in calculating a curve at any point on my current road. I've also decided to include my volume tables, which, as illustrated here, is 3 different tables showing the entire cut fill levels of my current road surface. On this slide, we can also see that my cut is much less than my fill, meaning that we will most likely have to import material in order to fill the necessary open spots on our surface. Typical sections. In my first illustration, I am showing the different layers of my road, which I've incorporated into my Civil 3D design. It illustrates a 50mm asphalt wearing course, a 150 G1 base course, and a 300mm C3 subbase layer. The second illustration is just an illustration of a stop street along with the dimensions, and this would typically be used throughout my entire road for all my stop streets. In conclusion, if my road design were to be chosen for the upgrading of the R33 Vaal Road, it would have to be re-evaluated after a structural design period of 25 years. This is to ensure safety and stability of the road and that it accommodates the growing growth rate. Thank you for your time.